All right, my mathletes, here we go. We've got warm-up number 3 from all the way back to 2012. Here's your answers. Number 31, each side of a regular hexagon. So regular means that all the sides are the same length and all the angles are the same measurement as well. So we've got a regular hexagon here. So each length is 6. What is the perimeter of the hexagon? Well, it's a hexagon, so there's 6 sides. And each of them are 6 because it's regular. So 6 times 6, I think our answer is going to be 36. Next, number 32. The graph shows the length of time it took 5 runners to complete a marathon. What is the median time? All right, so median, that is the number that is directly in the middle. So since there's 5 times here, 5 runners, we're only going to look for the middle one, which would be the third one. So these are the 2 lowest, these are the 2 highest. The medium one, the median, is this one. It's at 4, so our answer is 4. It's that easy. Remember, mean is where you have to take the average. The median is just the middle. So the middle amount would be 4 right here. Number 33, what is the product, so we're multiplying, of the greatest and the least 2-digit prime number? All right, so the least is pretty easy. That's 11. But the greatest 2-digit prime number, it's not 99 because 3 goes into both of those. It's not 98 because 2 goes into that one. So it's going to be 97. So we would just do 97 times 11. So that's 97 times 10 is 970. And then 97 times 1 is 97. So it looks like we're going to get 7, 6, 1067 as an answer. That is it. Next one, number 34. It takes a mechanic 4 hours to install carburetors in 3 cars. At this rate, how many minutes will it take the mechanic to install carburetors in 5 cars? Okay, so we've got a rate problem here. We've got 3 cars in 4 hours, but since the problem wants us to do it in minutes, let's do 3 cars for every 240 minutes. Okay, so that's our rate, 3 cars per 240 minutes. And then that should be equal to 5 cars, so cars is in our numerator, and we're looking for X number of minutes. Here's what I would do at this point. I would not multiply these numbers. I would just say, okay, 3x equals 5 times 240. And then I would divide by 3 on both sides. I'm not going to do any extra multiplication that I don't need. So I'm going to say, oh, 3 goes into 240 8 times. So 3 goes into 240 80 times. So now I know that my answer is 5 times 80, or my answer is 400 minutes. So when you're solving these quickly, don't do extra math that you don't need to do. So a lot of times that means don't multiply, especially if you know you're about to divide, because then you can just reduce the factors before you multiply, since you're multiplying smaller numbers. Number 35. In a certain parking lot, there are 2 black cars, 3 blue cars, 4 red cars, 3 green cars. If there are no other cars in the parking lot, so these are the only cars, what's the probability that a randomly chosen car from the parking lot is not green? All right, so we've got 2, 5, 9, 12. We've got 12 cars. How many of them are not green? Well, 3 of them are green, so that means 9 of them are not green. Yeah, so we're looking for not green out of the 12 cars, and they say express it as a common fraction, which means you need to reduce. So this is 3/4. Next. Becca is making 20 craft projects. She has 15 yards of ribbon, and each craft requires the same length of ribbon. What is the maximum length of ribbon each craft project can require in inches? Okay, inches. Okay, so here's how I would do this one. 15 yards. Well, there are 3 feet in every yard, so 15 times 3. And then in every foot, there's 12 inches. Notice I'm not multiplying these numbers together because I know I'm going to have to divide by the number of crafts in a second here. So instead of doing 15 times 3 is 45, then 45 times 12, I'm going to save myself some time and see if I can reduce any of the factors. And I can. Here, I've got 15 and 20. Since they're all factors, we can reduce them however we like. 5 goes into both of these, so this would become a 4, and this would become a 3. And then 4 goes into 12 over here, so 4 goes into 12 3 times. It's as simple as 3 times 3 times 3, 27. Again, we're trying to work smarter, not harder. So a lot of times you don't want to actually multiply the numbers if you know you're going to be dividing later on. So 3 times 3 times 3, answer is 27. 37, order of operations problem. All right, 2 divided by 4 times 8. Remember in PEMDAS, the M and the D, multiplication and division. A lot of people think, oh, multiply then divide. No, multiplication and division happens from left to right. So in this problem, I should be dividing first. 2 divided by 4 is 1/2, and then I multiply by 8. Half of 8 is 4. Multiplication and division happens from left to right. 38. What is the measure of the supplement, supplement of the smaller angle formed by the hands of a clock that displays a time of 4 o'clock? Okay, so there's some things that we need to know ahead of time. We know that supplement means it's 2 angles where the sum is 180 degrees. Okay, so if we're looking for the supplement, we want the other number we would need to make 180. Okay, so we've got an angle here at 4 and 12. So I want to know how many degrees so far are between 4 and 12. Now remember, it's kind of like the problem in warm-up 2 where we have a circle and we're talking about the central angles here. So if I have 360 degrees and I'm dividing by 12 for each hour here, that means each hour mark on here is 30 degrees. So I've got 30 degrees, 30 degrees, 30 degrees, 30 degrees, 30 times 4. This is 120 degrees inside of that angle right there. So what would be the supplement? The supplement would be the leftover amount we need to get to 180. So this angle is 120, its supplement would be 60. 60 degrees. All right, next one. Marita purchased an item for 45% off of the original price, plus an additional 20% off the sale price. She also had a $5 off coupon, which the sales clerk applied after these 2 discounts. Marita's final purchase price for the item was $50, assuming she paid no sales tax. That's helpful. What was the original price of the item that she purchased? Okay, so here's the first part, is 45% off, so she actually paid 55% of the original cost. I'm going to let X equal my original cost. And then from that, she took 20% off, so she paid 80% of this. And then she subtracted $5, and then that was the $50. Now for this problem, since we're not allowed to use a calculator, decimals probably aren't our best option here. So since this is in increments of 5%, hopefully you know that these are based off of a denominator of 20. So how many 20ths is 55%? Well, 5 goes into 55 11 times, so that's 11 20ths. And then over here, hopefully you know that 80% is 4/5. So this is 11 20ths times 4/5. Let's make this easier on ourselves and add 5 to both sides over here. And we've got 55 here. All right, so here's a little trick I'm going to do so that I don't have to worry about multiplying a lot. I'm going to change this over here since we're multiplying. This would be 11 times 4 in the numerator. Oops, 4. And then 20 times 5 in the denominator. All right, I need an extra piece of paper for this one. All right, so I want to get x by itself, so I would take the reciprocal of both sides. So I'm going to put 20 times 5 on top, 11 times 4 on the bottom. So here's what I got. X is equal to, the 55's on the top. I'm going to do the reciprocal, so 20 times 5 is going to go on top. And then our denominator is going to be 11 times 4, because I'm taking the reciprocal over here. And now I'm just going to start reducing. I see that 11 goes into 55 5 times. 4 goes into 25 times. So I just have 5 times 5 times 5, which is 125. There's my answer. So we're trying to, especially on these problems where we're multiplying, we are trying to do the least amount of work possible, which means a lot of times we're going to just leave things in their factors so we can reduce them later. Last problem. Multiplying a number by x yields the same result as dividing the number by 0.125. All right, so I'm going to take a number times x. So a number times x is the same thing as 0.125. Oh, dividing by, sorry. Is the same thing as dividing by the number, dividing it by 0.125. All right, so this is a problem where it helps to know that 0.125 is actually 1/8. So this is n divided by 1/8. And if you have a number divided by a fraction, I think we covered this in another lesson, we can take this denominator and just move it to the numerator. So this is actually n times x equals 8n. Divide both sides by n, and our answer is 8. Keep mathing hard, my friends. I will see you on the next lesson. Bye-bye.